All right, guys. So there was a little confusion about that formula that he gave you guys today, which was kind of a derivation of the formula that I had in my lab 3. So in order to clear some of the confusion a lot of you guys had this morning with that equation, I kind of took it upon myself to just kind of record this lecture-ish thing and figure out, or help you guys figure out how this equation works. So we'll start from the very beginning. First part of lab was finding our individual rock specific gravities. Well, specific gravity really is just density. So we get our density equals mass over volume, and then we take our numbers, which for part 1 was 1, 2, 3 for the number of rocks, and then for those individual weights we had 10, 8, scroll down over here, 9 grams, and then for the volumes we had 4, 3, 3.5 milliliters respectively. That gave us, once we plugged in this, a 2.5, 2.67, and 2.57 grams per milliliter respectively. Now, we can't use all 3 of these numbers because, frankly, it doesn't make a lot of sense. They're all the same rock. So we average it out, and that gives us 2.58. Now, if you were to kind of do a little extra work on, I think, lab 2, you would find the amount of rock and find the density from that by subtracting or adding the density and volume of water to that 1,000 milliliters, and you would get a 2.598. So we know these two numbers, they're basically identical for this class. So we'll just go ahead and use our 2.58 grams per milliliter as our density. Okay, so then we move to our mass. I'm just going to use the first example on my table, and for that it is the number 6 rock. So we started off with the tray weight, which is our empty weight. That's 10 grams. And then we got a total weight of 614 grams. Do some subtraction, and that gives us a dry aggregate weight of 604 grams. Right, so that is the rock in question. That is what we're trying to find the void percentage for. Not the wet weight, the dry weight, because the wet weight has already been saturated, so we can't take the calculation off of that. So we soaked that rock overnight, and then we took it out of the water, dried it off a little bit, and that gave us our SSD, saturated surface dry. So that just means the rock is fully saturated by means of the experiment, and the surface is relatively dry. For number 6 rock, we got a weight of 624 grams. Again, we take these two numbers, 624 minus 604, and we get 20 grams water weight. Right. So that's all you need. That's all you need for this next equation. And in order to kind of explain how I got to this equation, I'll just kind of talk about one thing. Voids do not exist. They're massless. Because it's the absence of the rock in this case. So we can't use mass and we can't use density because those both have masses as part of the units of them. So we need to use volumes. And in order to find the volumes of the rock, we just take our density equation and we rearrange it into volume equals mass divided by density, right? So we can't just use this number and just some arbitrary mass. We have to use this mass, which is our dry aggregate weight. So the dry aggregate weight, 604 grams, divided by our density, which we established as 2.58 grams per milliliter. Units cancel. And we get the volume. Now, the volume of that ended up being 234.11 milliliters. All right? So, this is our first volume. That is the volume of our dry aggregate, which is, like I said, the aggregate in question. Not the wet one, the dry one. So, what do we do for our the volume of our water? Well, water has a density of 0.9999998 grams per milliliter, which for this class might as well be 1 gram per milliliter. So we can take our 20 grams, divide that by 1 gram over milliliter, and that leaves us with 20 milliliters. Now you might be saying, what does this have to do with the equation? Well, really what the equation is a volume difference equation. So we have our volume of the dry aggregate minus the volume of the water. Divide that by the volume of the dry aggregate, and that gets us difference fraction. Take that, put a 1 minus, because this would just give us the volume of full rock compared to the void. So we'd get, like, I think in this case 92% if we were to not include this 1. So we take our 1 minus that, take all of that times 100%, and that will give us our void percent. So if we were to do this longhand for the number 6 rock, it would be 1 minus big bracket, then top of our fraction would be the dry aggregate weight, so 604 divided by 2.58, and that would be milliliters, minus our our water volume, which, easy enough, 20 milliliters. And then again, take that over the top of 604 divided by 2.58 milliliters. Right. Put that in there, times 100. And if you do the math right, you should get 8.54% voids.